Hi guys, this is Jonathan Lambert with Maths and Stats, and in this video, another video in our series of videos dealing with non-parametric correlation analysis, we're going to consider the case where we have two variables. The first, which is measured on a nominal scale of measurement, and the second is measured on an ordinal scale of measurement. But in this particular video, with respect to this correlation, we're going to assume that the nominal variable has more than two levels of measurement associated with it. In other words, it is multichotomous. So it is a multichotomous variable. And this ordinal variable is it's a ranked variable. Okay, so we have two variables, a multichotomous and a ranked ordinal variable. Maybe I'll just give you an example of what that particular data and what them variables might look like. So let's say within an organization, a very large organization, let's say, that we've kept track of individuals' roles. So their roles. So for example, they might be an executive. The first person might be an executive. The next person sampled might be an executive. The next person might be a manager. The next person might be a supervisor. The next person might be a manager. The next person might be a supervisor. The next person might be an executive. And we have this list of roles associated with individuals. But also, what we have associated with them is, let's say, a ranked score with respect to their, their salary. Okay, so what we have is maybe maybe not necessarily with respect to their salary, but maybe it's just a ranking with respect to them on some sort of test. So it's a ranking, so they have a ranking on some sort of test, and this test they undertook when they were doing their primary degrees. Okay, let's say, and everybody in the organization took this particular test. And let's say that the first executive is ranked number one. This manager is ranked two on the test. Let's say let's say this executive here is ranked three. Let's say, for argument's sake, that this manager is ranked four. This executive is ranked five. This supervisor is ranked six. And this supervisor is ranked seven. So what we have is we have a multichotomous nominal variable. In particular, there's more than two levels of measurements associated with this, and associated with every, let's say, individual, we also have assigned to them a rank. And what we'd like to do is we'd like to be able to calculate the correlation between this multichotomous nominal variable and this ranked ordinal variable. And as I've mentioned in previous videos, a great text is by Weary, and its contributions to correlation analysis. And Weary defines how to calculate the correlation between a multichotomous nominal variable and a ranked ordinal variable. And he defines these to be what's known as the missing formula. So in Weary, the correlation coefficient, it's based on the ranks, and based on the average ranks within groups, the ranks are defined to be the rank for this multichotomous variable with the ranked variable symbolized by or subscript m or is equal to, now this looks a bit complicated looking, but it's actually straightforward enough. So it's equal to 12 times, okay, the sum of, okay, for all of the multichotomies, in other words, for all of the groups, what we're going to do is we're going to look at the ranks within the groups, okay? So we're going to look at, we're going to sum up, let me get rid of that there. We're going to sum up the ranks within the groups, okay? The ranks within the groups. We're going to square that value. We're going to divide it by the size of the group, okay? And this particular value here is then divided by, and it looks pretty complicated looking, it's divided by the total number of observations times the total number of observations squared minus 1. And what we're going to subtract from that is we're going to subtract 3 times the total number of observations plus 1 divided by n minus 1. And more importantly, it's actually the square root. It's the square root of this particular formula. This looks pretty complicated looking, yeah, but it's actually straightforward to calculate. There's nothing really, look